All right, we're going to start off with factoring. And this is kind of just lined up goofy, but factoring begins up here with 67. And just keep in mind these things. Okay, find the GCF of the terms of the polynomial. GCF is greatest common factor. So we're looking for the largest number that can divide into both terms and the largest amount of variables we can take from both terms. The largest number that can go into 8 and 32, you might be thinking 2, 4, 8 can go into these, but we need the largest number. 8 is the largest number that divides into 8, and 8 is the largest number that also divides into 32. And then as far as the x's, this first one has 6 x's, the second one has 3. So the most that they have in common is just 3. So the greatest common factor here is 8x to the third. For 68, we have to find the greatest common factor and then actually factor it out. So we're looking for the numbers and the letters. With the numbers, what's the largest number that can divide into 2, 4, and 8? 2. And what is the largest amount of variables I can take from each one? They each contain at least one x, so I can pull out only one x because this term does not have more than that to give. When I am trying to rewrite this, though, I'm factoring this polynomial, so I'm going to rewrite it like a multiplication problem. When we do the greatest common factor, we write that term on the outside of the parentheses so it can distribute back in. So we could undo this. This original polynomial has 3 terms, so inside the parentheses I need 3 terms. So when I do this, I ask myself, 2x times what is 2x to the third? X to the second. 2x times what is positive 4x squared? Well, 2 times positive 2 makes positive 4, and x times x makes 4x squared. So 2x times 2x is 4x squared. 2x times what is positive 8x? 2x times positive 4 is positive 8x, and then that's my answer. Same thing here. Don't be afraid to hit pause. Try this without me. The largest number that can go into both of these, 16 does not go into 40, so I believe the largest greatest common factor, the largest factor is going to be 4, and they both have at least 6 of those w's in common. And so now I'm going to rewrite this. There were 2 terms in the original polynomial, so inside my parentheses needs to be 2 terms. 4 times what makes 40? 10. W to the 6th times what makes w to the 11th? W to the 5th. 4w to the 6th times what makes positive 16w to the 6th? Positive 4. Okay. Now we're getting into trinomials, but just keep in mind that we always want to start by asking ourselves if there's a greatest common factor. Then we ask ourselves how many terms are there, and for a lot of these there's going to be 3 terms, which means we're going to factor into 2 sets of parentheses. So I have 3 terms here. I'm going to try to factor into 2 sets of parentheses. Factors of the first term, w times w, have to go in the first spots. Factors of the last term need to go in the last spots. So 1 times 77, 7 times 11. I don't know if there's more. I could spend more time on it, but first I want to ask myself, do any of these combinations create an 18? And the answer is yes. So I'm going to plug that in. And then when it comes to creating my signs, the last sign tells me if the signs inside are going to be the same or if they're going to be different. Because the last sign is a plus sign, that tells me they're going to be the same. They're either plus plus or minus minus. To figure out what set I use, I'm going to look to the first one, and since the first one's a plus sign, then I use the plus signs. This is the answer, but I strongly recommend you draw your bridges to check your work or multiply the whole thing out like you did in one of the prior lessons, like what we did here. If you multiply this back out, you get two middle terms that combine to give you this middle term. The other way to check that is with bridges. 7 times W is positive 7W. W times 11 is positive 11W. And together, when you combine those, they make positive 18W. That means if I were to multiply this entire thing back out, I would get a middle term that makes 18W. So I did this correctly. All right. Again, hit pause. Try this one without me. You have the tools to do it. I'm going to try, there's no greatest common factor, so I'm going to 2 sets of parentheses. Factors of the first term go in the first spots. The only way to do d squared is d times d. Next, factors of 9, 1 times 9, or 3 times 3. The combination that can make a 10 is the 1 and the 9. The last sign is a plus sign. That tells me that the signs inside are either going to be plus plus or minus minus. So I look to the first sign, it's a plus, so I'm going plus. So this is my answer, but I should check my work. 1 times d is 1d, d times 9 is 9d, and together those add up to make 10d, which is our middle term, so we did that correctly. There's no greatest common factor among these 3 terms, so I am looking for factors of x squared. The only combination is x times x. 42 is going to be 1 times 42, 2 times 21, or 6 times 7. And I'm looking for a combination that can make a negative 1. And I noticed for the first time my sign, the last sign is a minus sign. That tells me the signs inside are going to be different. That means one's going to be a plus sign, one's going to be a minus sign. That means that I'm subtracting these numbers to make the middle term. So this is basically a 1, and the combination that makes a 1 is the 6 and the 7. Now, to figure out where I place the plus and the minus, I can use my bridges to help. I need this combination to make a negative 1x. If the inside bridge gives me the 6x, the outside bridge gives me the 7x, where do I need to place the minus sign so that way they combine to make a negative? The answer is with the larger number. If I want my answer to be negative, the larger number needs to be negative when I add them together. So that means it's going to be a plus 6 and a minus 7. Same thing, try it without me. Hit pause. Factors of the first term go in the first spots. For 49, it's 1 times 49, or 7 times 7. I need to make a 14. 7 times 7. The last sign is a plus sign, so that tells me that the signs inside are either plus plus or minus minus. Because the first sign is a minus, they're minus minus. This is my answer, but I check my work. The inside, negative 7 times d is negative 7d. The outside, d times negative 7 is negative 7d, and when I add those together, they make negative 14, which is my middle term. Is there a greatest common factor? No. So there's 3 terms. I'm going to try to go for 2 sets of parentheses. This one's a little different than the previous ones because now, instead of just x times x, it might be 1x times 6x or 2x times 3x. So before I place those in the first spots, I'm going to see what other things I know for sure before I write this down in pen. Factors of the last term, the only way to make 1 is 1 times 1. So I know for a fact that the last terms have to be 1 and 1. I also know for a fact that the last signs have to be the same and that they both have to be plus signs. So this information I know for sure. The only thing I just don't know yet is what I'm putting here. And so what I can do is plug something in, and you probably should do this with pencil. because if you plug it in and it doesn't work, you have to try your other options. I'm going to plug in 2x and 3x, and so I'm trying this one out, and if it doesn't work, I need to go back and try the other option. 1 times 3x is positive 3x, 2x times positive 1 is positive 2x, and together those make positive 5x, which is my middle term. So this was my answer. All right, we are getting a little bit more challenging with this one. Do we have a greatest common factor? No, because this one is, the only way to make 55 is 5 times 11, and 5 does not go in the other terms. So I'm gonna try this. Now, factors of 21 is either 1x times 1x or 3x times 7x, and 14 is 1 times 14 or 2 times 7. So this one's going to be a little bit more challenging because we have a couple of options for both spots. The only thing I do know for certain is that my plus sign, or inside I have to have the plus signs. So I'm going to use a pencil as I try to figure this one out. And I guess I'm going to try this and this to start, and we'll see what happens. So I'm going to plug in 3x, 7x, 2, and 7 and see what happens. So when I'm drawing my bridges, which I'm probably going to have to erase a couple of times here, the 2 times 7 makes 14x, the 3 times 7 makes 21x, and together those make 35x. That is not big enough. So then the question becomes, if I swap one of these combinations, can I get a larger number? So I'm going to try and move my 7 over here and the 2 over here, and that will make a bigger combination because 7 times 7 is 49, and then 3x times 2 is 6x. And by some sweet miracle, we have found our answer quickly. That's why it's a miracle, because we only had to do this twice. That made, yep, so we're good. All right, same thing. Is there a greatest common factor? No, because 11 is a prime number. So try this one without me. Hit pause, rewind, do what you need to do. Factors of 6 are going to be 1g times 6g or 2g times 3g. And then for 35, we have 1 times 35 or 5 times 7. Again, and the last sign is a minus sign, so that means that my inside signs have to be opposites. So we have a lot of mixes and matches that we can do. Because the number is 11, I'm gonna start off with like smaller numbers and see what happens here. I'm gonna draw my bridges, but other than that, everything is a mystery. So I'm going to try 2g and 3g to begin with, and then I'm going to plug in the 7 and the 5 to start and see what happens. 7 times 3 is 21g, 2g times 5 is 10g, and again, those do actually make 11g if I subtract them, which I'm gonna have to because my signs have to be opposites. So I got lucky again. You get better at getting lucky the more of these you do. You go with your instincts. I went with smaller numbers because I knew that I needed a somewhat smaller number inside, and so that was why my instincts led me there. I need a positive 11g, which means this larger number, 21g, needs to have the positive, and the negative 10 needs to be the negative. So that means that this outside bridge is negative, inside bridge is positive. This one, if we think about this little guy here, there is no greatest common factor. There are 2 terms, so we're going to try difference of perfect squares. Difference of perfect squares meant that we have 2 sets of identical parentheses, except their signs are opposites. So we do difference of perfect squares, 1, if we have a subtraction sign, which we do. And then can we take the square root of r squared? Yes. The square root of r squared is r. The square root of 49 is 7. So the square root of the first term goes in the first spots. The square root of the last term goes in the last spots. And then we have to have opposite signs. That's it. And what happens with these, if I multiply them back out, the inside bridge gives me 7r, the outside bridge gives me negative 7r, and when they combine, they make 0r, which is why there is only 2 terms here. 0r would be in the middle. And so we have, that only happens when we have identical parentheses with opposite signs, that middle term will cancel. So try this one on your own. There is no greatest common factor here, but the square root of 49b squared is 7b, and the square root of 36 is 6. So I have the subtraction sign. I'm going to do the square root of the first term in the first spots, the square root of the last term in the last spots, and opposite signs. Factor by grouping is something that we did not do in class, so it's okay if you skip 79 and 80. Miss C's class did this, but if you group the first set and the last set, then we're looking for greatest common factors among these groups. So in this first one, the greatest common factor is 2g squared, and so then 2g times 3g is 6g to the third. 2g squared times positive 4 is positive 8g to the squared. Next, the greatest common factor among the second group would be negative 5, and then 5 times 3g makes 15g. Negative 5 times negative, I want to make that positive. Negative 5 times negative 4 makes this a positive 20, so I need this to be a positive 20. Or I'm sorry. Negative 5 times positive 4 makes that a negative 20, so I need that to be a plus sign, which makes sense because now if I look, I have these two things getting multiplied together and these two things getting multiplied together. So if I look at common factors among those two groups, this is a factor from the first set of terms, and this is a common factor from the second set of terms. So I'm going to factor that out, and then whatever remains goes in the second group. And then that's it. That's our answer. So you might need to rewatch that, especially since I went a little slow on it. Same thing. First group, greatest common factor would be 10k squared. 10 times 5k. 10k squared times 5k makes 50k to the third. 10 times negative 4 makes negative 40, and then k to the squared. And then the greatest common factor among these, let's see, it's going to be 15. So I'm going to pull out 15. 15 times 5 makes 75k. 15 times negative 4 makes negative 60. So again, if you can start to see it, these two things are getting multiplied together. These two things are getting multiplied together. So what common factor do they have? 15k to the fourth. So that's going to common factor out in front. And what's left behind goes in the other parenthesis. So that's our answer. Alrighty.